Good morning, everybody. Welcome to your Unit 3 Investigating Force and Motion CBA. I'm going to read the test to you. Please listen to every question and answer choice carefully. Pause the video if you need to at any time to listen to a question read to you again, or if you need a little time to think about your answer choices. Question number 1. The energy related to the motion of an object is called, is it A, potential energy, B, kinetic energy, C, electrical energy, or D, chemical energy? Number 2, the graph below shows the position of a moving object from 0 to 5 seconds. There's your graph. According to the above information and the graph, which of the following statements is true for the moving object? Is it F, the moving object is accelerating and changing its speed through the measurement? Is it G, the moving object is traveling at a constant speed through the measurement? Is it H, the moving object is slowing down and finally stops at the 5-second mark? Or is it J, the distance the moving object travels is the same for each second? Number 3, a student who was training for a cross-country race jogged for 2 hours, 2.0 hours, and covered a distance of 14.0 kilometers. What was the average speed of the student? Do not forget your distance formula, your speed formula, which is distance divided by time, please. A, 28.0 kilometers per hour, B, 7.0 kilometers per hour, C, 12 kilometers per hour, or D, 0.14 kilometers per hour. Number 4, a student wants to safely be able to move a cart up a ramp and onto a truck. To see which ramp would be most beneficial, the student investigates to see how the length of the ramp changes the amount of force needed to move the cart. This is measured in newtons. So we have these options. The ramp that's 5 meters high, 8 meters long, the student needs 50 newtons of force. The ramp that is 5 meters tall and 10 meters long, the student needs 40 newtons of force. And the next option is a ramp that is 5 meters tall and 20 meters long, needs 20 newtons of force. Which of the following conclusions can the student make from the investigation about how to safely move the cart? Is it F, as the height of the ramp increases, the amount of force needed increases? Is it G, as the length of the ramp increases, the amount of force needed decreases? Is it H, as the length of the ramp increases, the amount of force needed increases? Is it J, as the height of the ramp increases, the amount of force needed decreases? Number 5, a student hit a high fly ball over second base in a championship softball game. As the ball rises in the air, it is acted on by the force of gravity. This force causes the ball to do what? Is it A, slow down, change direction, and then speed up as it falls to the ground? B, speed up, keep its same direction, and then slow down as it falls to the ground? Is it C, travel at the same speed until it hits the ground? Or is it D, travel in the same direction until it hits the ground? Use the diagram below to answer the next 2 questions. So you have this diagram of a roller coaster. Number 6, according to the above diagram, at what point would the roller coaster car have the greatest kinetic energy? Is it F, number 3, G, number 4, H, number 5, J, number 6? Which point would it have the greatest kinetic energy? Number 7, according to the above diagram, at what point would the roller coaster car have the greatest potential energy? Is it A, number 3, B, number 4, C, number 5, D, number 6? Number 8, a 55-kilogram student was riding his skateboard to school. He traveled 200 meters in 40 seconds. What was the student's average speed in meters per second? Record your answer and fill in the bubbles on your answer document. Be sure to correct your place value. Number 9, during an investigation, students placed a toy car at the top of a ramp and recorded the distance and time at different intervals. The graph below is a record of their data. What is the average speed of the toy car during the investigation? Is it A, 2 meters per second, B, 4 meters per second, C, 6 meters per second, or D, 13 meters per second? Number 10, which inclined plane requires the most force to push the ball up to the top? Which one of these inclined planes or ramps is going to take the most force to push the ball up? Number 11, the graph below shows the motion of a car. Which statement below best describes the motion of the car? Is it A, the car stopped for 2 minutes, travels at a constant speed for 2 minutes, and then stops? Is it B, the car stopped for 2 minutes, increases its speed over 2 minutes, and then stops? Is it C, the car travels at a constant speed for 2 minutes, increases its speed for over 2 minutes, and then travels at a constant speed for 2 more minutes? Is it D, the car increases its speed for 2 minutes, travels at a constant speed for 2 minutes, and then increases its speed over the next 2 minutes? Now I want you to listen very carefully. The amount of time isn't really important. What is important in this problem is what type of motion is taking place here. Think about what we've talked about and what a motion graph looks like. Number 12, a ball is given a single push up an inclined plane as shown. Which of the following will not change as a result of the unbalanced force of gravity? What is not going to change? The position of the ball, the speed of the ball, the mass of the ball, or the direction of the ball? One of these things will not change. Number 13, observe the inclined plane and the ball in the above image. If the ball rolls down the inclined plane in the direction of the arrow in 2 seconds, what is the average speed of the ball during the roll? Remember your speed formula, distance divided by time. Number 14, a dog walks away from home at a constant pace for 20 minutes. Next, he stops for a 10-minute nap under a tree. Finally, the dog walks back home at a constant pace and comes to a stop. Which graph below best represents the motion of the dog in terms of distance from home over time? So we're looking for which graph represents the motion of the dog. Pay attention to not necessarily the times, but the motions that the dog is walking in. Is it F, G, H, or J? Number 15. Make sure you pause the video if you need to go back and look at these graphs or look at your test. Pay attention to number 14. Number 15, during field day, a student recorded the motion data of a runner. The runner recorded the distance traveled every 10 seconds and represented the data in a graph. Based on this above information, what is a valid conclusion? Like, what can you basically decide that the student can make about the runner's motion? Just the runner's motion, got to describe it. What do you see here? Remember your motion graphs. Is it A, the average speed of the runner remained constant as the runner covered more distance? Is it B, the average speed of the runner increased as the runner covered more distance? Is it C, the average speed of the runner decreased as the runner covered more distance? Is it D, the average speed of the runner increased and then remained constant as the runner covered more distance? We have 2 more to go. Number 16, students placed a steel ball at the top of a long piece of tubing track. As the ball rolled down the track, the students measured the distance of the ball that the ball had traveled at various times. The graph below is a record of their data. According to the information in this graph, what unbalanced force is affecting the steel ball, and how is it affecting the ball's motion? Is it F, friction with the track is the greatest unbalanced force, and it's causing the ball to slow down? Remember your motion graphs. What are we seeing happen here? Is it G, friction with the air is the greatest unbalanced force and is causing the ball to slow down? Is it H, gravity is the greatest unbalanced force and is causing the ball to speed up? Is it J, the initial push of the ball is the greatest unbalanced force and it's causing the ball to speed up? Number 17, last problem. 2 great snipe birds are migrating. I don't think a snipe bird is real. Those look like crows, just saying. 2 great snipe birds are migrating. I'm gonna have to look that up. Both birds have a mass of 100 grams and are flying at 90 kilometers per hour. Bird R is flying 2 kilometers above the ground. Bird Q is flying 2.5 kilometers above the ground. Based on the information above, which statement best describes the energy of the 2 birds? Really, for this problem, the numbers aren't really a whole lot important, just which bird is higher and which bird is lower, okay? Don't get tripped up by this one. Based on the information above, which statement best describes the energy of the 2 birds? Bird Q and R have the same kinetic and potential energy. Bird Q and R have the same kinetic energy, but different potential energy. Number C, birds Q and R have no kinetic energy, but have the same potential energy. And D, bird Q and R have the same potential energy, but different kinetic energy. Think about this one. What are you seeing here? All right, I need to look this up. Great snipe bird. I gotta see if this is for real. Is this for real? What? That ain't no great snipe bird. That don't look nothing like a great, that thing's little. I don't know about this question. I'm gonna have to talk to somebody about that. All right, well, there's a snipe. They're real, but that don't look like a great snipe bird. Good luck on your test. Please rewind the video, pause the video, rewind, listen to any questions you need to hear again, and good luck.